This video is for Mastery and Homework 1.8, Section 5.5 in your textbook, Order of Operations and Complex Fractions. What we're going to look at here is looking at the order of operations whenever we're dealing with fractions, and especially complex fractions. When we talk about order of operations, we're still going to follow the general order of operations. What I mean by that is we still look at performing operations inside grouping symbols, then we simplify our exponents, then we do multiplication division in order from left to right, do addition and subtraction last, working from left to right. But if a fraction has operations in the numerator or in the denominator, or both, these operations must be done first. We must simplify the numerator and simplify the denominator before we simplify the entire fraction itself. Inside the numerator and denominator, we follow the generic order of operations themselves. So let's look at some examples. First of all, if we have 5/6 squared plus 1/12 minus 1/4, we notice that we don't have a complex fraction. All we have are fractions added and subtracted. When looking at this, I have a set of parentheses, but there's nothing to simplify inside those parentheses. So I do not have to do anything as far as the grouping symbols. My first order of operation that I do have to do is my exponent. I have 5/6 squared. This actually means 5/6 times 5/6. Remember, whenever we're multiplying fractions, we take numerator times numerator and denominator times denominator. And therefore, I would get 25 over 36 when I multiply 5/6 times 5/6, as I have shown here. This would simplify my exponent. Now that I have simplified my exponent, I am left with addition and subtraction only. I have no multiplication division. Before I add or subtract, I must first find a common denominator, my LCD. Looking at my current denominators, 36, 12, and 4, I notice that 36 will be my LCD. Once I find my LCD, I must figure out what I multiply the 12 and the 4 by to get 36. I must multiply 12 by 3 to get 36. Remember, what you do to the denominator, you must also do to the numerator. I've done the same thing with the 4. 4 times 9 will give me 36, and I must multiply the numerator by 9. When I do so, that will give me 25/36 plus 3/36 minus 9/36. Now I can add and subtract the numerators, since my denominators are all the same. So I will put them all on one fraction on the numerators and simplify. And I will get 19/36. My last step is always to see if I can simplify my 19/36. Now then, notice I have 19 as a prime number, and it does not simplify with 36. So 19/36 is my final answer. Now then, when I talk about complex fractions, these are fractions that contain at least one fraction in the numerator or in the denominator. If you notice, I have three sets of complex fractions here. I have a fraction over a fraction, or I have a fraction plus a number over a fraction, or this one where I have a number minus a fraction over two fractions added together. I have fractions within the numerator and or denominator. Again, I must simplify the numerators and denominators before I do the last division. Let's look at some examples. Here I have a negative 3 squared plus 7 in my numerator and a 4/5 in my denominator. Well, my denominator is already simplified as far as it can go, 4/5. My numerator, I must simplify it. So I will first simplify negative 3 squared, which will be 9, and 9 plus 7 will give me 16. I have simplified this entire numerator into 16. Now, when discussing complex fractions, what I'm going to do is I'm going to take the numerator divided by the entire denominator. And so I say 16 divided by my 4/5. This way I have it set up as a division problem with fractions, because we know how to divide fractions. This makes it much easier for us. Remember, whenever I'm dividing fractions, I keep my first fraction, change my sign to multiplication, and flip my second fraction. So I now have 16 times 5/4. I multiply numerator times numerator and denominator times denominator. Remember that when you have a whole number, you think of it as over 1. And I'm going to go ahead and write 16 and times 5 over 4 out in their prime factors. So I've rewritten 16 as 2 times 2 times 2 times 2, and then times my 5. And I've written 4 out as 2 times 2. What this allows me to do is this allows me to go ahead and simplify. This allows me to cancel out a set of 2's here and a set of 2's here, as I've shown. Now I'm left with 2 times 2 times 5, which will give me a final answer of 20. So a negative 3 squared plus 7 divided by 4/5 is 20. Let's look at another example. I have x squared over 12 divided by x over 6. Well, there's not much to simplify in my numerator or in my denominator, so I set them separately as a division problem. X squared over 12 divided by x over 6. Then I change it from division to multiplication by flipping my second fraction, and I get x squared over 12 times 6 over x. I multiply numerator times numerator, denominator times denominator, and I'm going to go ahead and simplify my 12 as 2 times 6. This shows me that the 6's will cancel out. And I'm also going to think of x squared as x times x. This lets me see that I've got an x that I can cancel out. This allows me to see that my final answer will be x over 2. Let's look at another example. I have 2/3 plus 1/6 divided by 3/4 minus 1/2. So I think of it as I have to simplify the numerator and then simplify the denominator first. So I have got to get a common denominator for the numerator and a common denominator for the denominator. My common denominator for the numerator will be 6, and my common denominator for the denominator will be 4. And so if you notice, I'm multiplying my 2/3 by 2, and I'm multiplying my 1/2 by 2. This now gives me 4/6 plus 1/6 and 3/4 minus 2/4. This allowed me to change and get common denominators on both numerator and denominator. I can now add and subtract my numerators on both sides of the fraction, and I get 5/6 divided by 1/4. Change this into a division problem, so I have 5/6 divided by 1/4. How do we divide fractions? We flip the second one and we multiply. Now I simplify and reduce my numbers into their prime factors. 4 is the same thing as 2 times 2. 6 is the same thing as 2 times 3. I can cancel out a set of 2's, and I'm left with 5 times 2, which is 10, over 3. Now if you've noticed, complex fractions can be reduced into simple division problems of fractions. You just have to make sure that you simplify out the numerator and the denominator individually before changing it. Make sure that you're getting common denominators on each numerator and denominator separately before you proceed. If you have any questions or need any help, please let one of us know.